one of the fundamental theorems we're going to be working with when we're looking at number theory is something called the division algorithm. Now, this isn't a huge concept to understand, but it's fundamental when it comes to us when we're working with Euclidean algorithms and beyond. Now, the division algorithm is all based around a single premise involving numbers. What it states is that if we've got any two integers a and b, we're going to call a the dividend and we're going to call b the divisor, and the condition we're going to put on it is that b cannot be equal to 0. There exist any two numbers somewhere, q and r, and we're going to call them the quotient and remainder respectively, such that we can write a in a format of q times b plus r. So something times the divisor plus a remainder. And a key thing here is that the remainder lies somewhere between 0 and the magnitude of b. So between 0 and the size of whatever the number b is. So say b was 3, the divisor, the remainder, would lie somewhere between 0 and 3. Putting it simply, what it means is we can express a dividend, so a number, as a combination of a divisor and a quotient with the remainder. And this creates a unique expression. Nice simple example of this is the number here. So I've got 36, and what that is equal to is 5 times 7, then plus 1. So in this example here, my dividend, my a, is 36. My divisor is b, which is my 7. My q and my r, so the quotient of the remainder, the quotient q is given as 5, and the remainder is 1. So basically what it's saying is, if I were to divide 36 by 5, I'd get an answer 7, and I'd have a remainder 1. So it's quite simply put that way. Now this gives us a format which we can use when we're working with Euclidean algorithms and looking at greatest common divisors for numbers. Let's just get a little bit of practice here at how we would write numbers using this division algorithm. So let's imagine I've got these three examples here, and what I'm going to do is I'm going to calculate the following in the format: a equals qb plus r, where 0 is less than or equal to r less than or equal to the size of b, and I'm going to state the divisor, the dividend, the quotient, and the remainder for each of these. So what I'm going to look at is this first one here, so 17 by 5. So what this means is my dividend in this case is 17, that's the number that's going to represent the a. My divisor is the 5. So that's the number that's going to represent the b. That's essentially, you could say to yourself, what you're dividing by. So for this one, I'm going to do 17 is equal to something times 5 plus a remainder. So we have to then figure out 5 times what will get me to 17, or get me below 17, but not above it. Well, if you think 5 fours are 20, that's above the 17. If we think 5 threes are 15, that's below the 17. So that then means that 17 is going to be 3 times 5 plus a remainder, and in this case, if I've got 15, 3 times 5, my remainder is 2. So in this case, my divisor is 5, my dividend is the 17, my quotient is 3, and my remainder is 2. So I could equate it up to the a, the b, the q, and the r in such a manner there. If I look at the next one, negative 23 by 4. So again, this means I'm going to be looking at writing the number in some format of negative 23 times 4 and then plus a remainder. So what we're going to do is we're going to say negative 23 is equal to something times 4 with my remainder. Keep that question in our heads. Well, it's going to be a negative number because it's negative 23. So negative something times 4 gets me close to negative 23. Well, if I do negative 5 times 4, I'm at negative 20. If I do negative 6 times 4, I'm at negative 24. So that gets me closer than the other one. So I could say negative 23 is the equivalent of negative 6 times the 4. I'm then going to add on my remainder, because remember this condition here. My remainder has to be between 0 and the size of b. So it has to be somewhere between 0 and 4. Now, if I'm at negative 6 times 4, I'm at negative 24. So I can then add on 1, and that'll take me to negative 23. So that then means that I've got my dividend, a, which is that, which is negative 23. My divisor, which again we equate to being b, that's the 4. We've got our quotient, which is negative 6, which is q, and our remainder r, which is the plus 1. Looking at this last example, 322, again we're going to ask ourselves the same question. I want it in a format of 322 equals something times 5 plus a remainder. So again, say to ourselves, 5 times what gets me close to 322? Well, in this case, if I do 64 times 5, that'll get me to 320. And if I then add on 2, that gets me to my 322. So that gets me the solution I want in the right format. And then here, my dividend, A, is the 322. My divisor, which was the B, is 5. My quotient, which was the Q, is 64. And my remainder is 2. So they're all into the same format that we're after. Now, writing it in this format is something vital when it comes to working with our Euclidean algorithm next, and when it comes to looking at finding greatest common divisors. But being able to write it in this format is vital, because ultimately what we're going to do is to find greatest common dividers. What we need is a remainder of 0. So we have to know this format to continue to break numbers down, such that we get to a point where my remainder is 0, and we can use that to apply the Euclidean algorithm and any further theories that we want.